equation in vertex form. 1/2 x plus 6 squared minus 15. Write down what you think the vertex of this is going to be. Hopefully you just did it before me, and you're looking at this and you're saying, okay, the vertex of this thing should be, it's not going to be 6, it's going to be -6, -15, right? This is either going to be the high point or the low point of this particular parabola. And I can see it because it's in this form. I can see the vertex directly in that form, all right? So now, let's get into these key features of the parabola, all right? So first, let me give you a parabola, or here's an equation of a parabola in vertex form. It says y equals 2 times x plus 3 squared minus 4. What I want you to do before I do it right now, go ahead and make the top 2 columns of the Gema table. Don't fill out any values for x, but make the top 2 columns of the Gema table. Pause it, do that right now. Cool. Hopefully, you're a good student and you attempted to do that before me just to see if you could get it right, because that helps you get on the right path. So I'm going to do this column. I know this column starts with x. I know I'm going to follow Gema. So I see grouping x. The first thing that happens to x is plus 3. This gives me x plus 3. Okay? Exponents. I see it's squared. So I'm going to take that and square it. So I end up with x plus 3 squared. Multiplying and dividing. I see it's times 2. So I'm going to times 2. So now I get 2x plus 3 squared. And adding or subtracting, finally, end up with minus 4. So end up with 2x plus 3 squared minus 4. All right? So I just built that Gema table, the top 2 rows. These are my headings. These are the actual operations that happened that helped me to build it. Okay? Now, I'm going to use this Gema table to actually find out really important pieces about my parabola. Now, one of the cool things, actually, let me put it over here, that we know about parabolas is they have this, this quality where they kind of mirror each other, right? This is a mirror reflection of this side. This is a mirror reflection of this side. This is a mirror reflection of this side. And you have like this either high point or low point. That's the vertex. So with this in the Gema tables, I always want to start at my vertex so I can see this mirroring, so I can see this symmetry right in the table. And you're going to see it here right now. So one of the things I need to know is, where is the vertex in this particular situation? Hopefully you're looking at it and you're like, oh yeah, I got this. This is vertex form. So I know the vertex of this one is going to be -3, -4. When x is -3, y is -4. That's going to be my vertex, right? So what I'm going to do is I'm going to start with my vertex and I'm going to start it in the middle of the table so I can see the symmetry. And just stick with me here. So I'm going to start it, I'm going to say, oh, about here. And I'm going to say x is -3 because that's what x was in my vertex. I'm going to find my vertex. I should get -4 when all is said and done. Let's see if this works. Okay? So x is -3. -3 plus 3 is 0. 0 squared is 0. 0 times 2 is 0. 0 minus 4 is -4. Booyakashao. There's my vertex. And I'm even going to label this vertex. Now I'm going to end up looking on each side of my vertex, right above it, right below it, to see if I can find that symmetry that we were talking about here. Because I now know my middle point. I want to see if I can find the symmetry. So I'm going to go to -4 here. I'm going to move 1 in the negative direction. -4 plus 3 is -1. -1 squared is 1. 1 times 2 is 2. And 2 minus 4 is -2. Okay? Let's see if this symmetry happens. Now I'm going to go 1 in this direction. So this is going to be a -2. -2 plus 3 is 1. 1 squared, oh snap, is 1. 1 times 2 is 2. 2 minus 4 is -2. We see the mirroring. Let's try it one more time. Let's move another one. Negative 5. Negative 5 plus 3 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 4 is what? No, not times. 8 minus 4, excuse me, is 4. Let us see what happens on this side. We're going to go negative 1. Negative 1 plus 3 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. See this symmetry. I go from negative 4 to negative 2 to 4, right? So I can see it mirroring just like it mirrors in the graph, okay? So if you were actually graphing those points, if I wanted to graph this thing right now, I know the vertex is at negative 3, 4. So here's negative 1, 2, 3, 1, 2, 3, negative 3, excuse me, negative 4, 2, 3, 4. So it'd be here. And then I see at negative 4, I'm at negative 1. At negative 3, wrong. At negative 4, I'm at negative 2, excuse me. Negative 4, negative 2. And at negative 2, I'm also at negative 2. So negative 2, I'm also at negative 2. And then at negative 1, I'm at 4. So here's negative 1, x is 1, 2, 3, 4. It's like here. And at negative 5, which would be right here, I'm also at 4. So you can see how these are mirroring. This is mirroring, showing just how this mirrors over here. Hopefully you can see that. Yeah, you can. Good, 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 good. Okay, so I just found the vertex right here. But now there is more stuff that I could find in a second, and we'll look at that pretty soon. But I wanted to make sure that you saw the mirroring. So there is your first one right there. Now let's say though, in this situation, actually let me just give you another one. And we're gonna find a different piece. We're gonna find the x-intercepts and the y-intercepts. We'll start off with our vertex. There we go. So here's your next equation. It says y equals negative 6 times x minus 5 squared plus 7. Do me a favor. Give me the first two columns and give me the vertex row. So give me the first, the headings at the top, so the operations and building the equation, and then right smack dab in the middle, show me where the vertex is going to be. You do that now. Cool. Hopefully you did it or attempted to do it before I did. Now I'm going to build it so you can check to see if what you did is right. All right. So as always, I'm starting with x. I'm following Gema, minus 5. Following Gema, squared. I'm following Gema times negative 6. I'm following Gema plus 7. Okay, so hopefully you built yours and it looks just like that. Then from here, hopefully you went down to the middle and you're like, all right, well, what is the vertex? Well, I know in this one, the vertex is 5, 7, because it's the opposite. It says minus 5, so it's the opposite, it's 5, 7. So I'm going to go 5. Hopefully I end up with 7. So let's see. 5 minus 5, 0. 0 squared, 0. 0 times negative 6, 0. 0 plus 7, 7. It's what I want. Here's my vertex. Okay? Notice these rows of zeros in vertex form, these are always going to happen at your vertex. And notice why it's the opposite. Notice this says minus 5, but to get that 0, we had to put in positive 5, right? So that's why x became 5, because that's what created this 0 right here. And that's the row of zeros that we need. So now we're just going to make sure we can see the symmetry on both ends. So I'm going to right here, I'm going to call this one a 4. We're going backwards, yeah, 5, 4. So 4 minus 5 is negative 1. Negative 1 squared is 1. 1 times negative 6 is negative 6. Am I correct still? 4 minus 5 is negative 1. 1 minus 1 times negative 6 is negative 6. And negative 6 plus 7 is 1. All right, if this thing worked, hopefully this should end up being a 1. Let's see if I messed it up or not. So this will be a 6. See if our symmetry happens. 6 minus 5 is 1. 1 squared is 1. 1 times negative 6 is negative 6. And negative 6 plus 7 is 1. I see my symmetry. I'm feeling pretty confident that I have my vertex. I can see the symmetry on each side. Last thing I'm going to ask is, well, what if I want to find a y-intercept? Well, what happens at a y-intercept? What is my x value of the y-intercept? Hopefully you're like, oh yeah, x is 0. So cool, y-intercept, I'm just going to put it up here. I'm going to say x is 0. 0 minus 5 is negative 5. Negative 5 squared is 25. 25 minus 6 is 19. 19 plus 7 is 26. This right here is my y-intercept. All right, here's the last thing that we're going to do now. We found vertex. You know how to find that in the Gema table. We have found x was 0. So that's y-intercept. You know how to find that in the Gema table. Now we're going to look at x-intercepts with this Gema table. So build me the Gema table, please. You should do it faster than I am. Actually, you should just pause and do it before me. Cool, you did that? We got x plus 8 squared times 2 minus 2 okay, so hopefully you built that Gema table. All I'm going to show you is finding the y is 0, the x-intercepts right now. So if I want to find an x-intercept, I know that y needs to be 0 because the y value of every x-intercept is 0. So I'm going to start with 0. And I'm going to work backwards. I'm going to do the opposite. 0 plus 2 is 2. 2 divided by 2 is 1. 1, the opposite of squaring is a square root. The square root of 1 is 1. And 1 plus 8, so minus 8. 1 minus 8 is negative 7. This is a y-intercept. Oh, why do I keep saying the wrong thing? This is an x-intercept because y is 0. Okay? So usually there are 2 x-intercepts. And there was one spot in here where we actually had 2 possible answers. See if you can figure out where that spot was. All right, now I'm going to walk you through. There are usually 2 x-intercepts, right? So there are 2 places where y equals 0. So I'm going to go here. 0 plus 2 is always going to be 2. 2 divided by 2 is always going to be 1. What is the square root of 1, though? Well, the square root of 1 means 2 numbers times themselves that equal 1. Well, 1 times 1 is 1. But also, negative 1 times negative 1 is 1. So the square root of 1 could be either 1 or it could be negative 1 because 1 times 1 is 1.